Good afternoon. We are the IC Engineers. Our name was inspired by us being cool and fresh innovators, and I want to basically describe our machine for the 2110 competition. So the team is composed of Park, Dakari Cuts, Ramel Bailey, and DJ. Our design process, we use an iterative design process where we improved our design by ideating and implementing those ideas, then testing how well it functioned and repeating the cycle. So essentially, throughout this design competition, we were going through different iterations of this design and, seeing what worked or what didn't. And basically from there, trying to week by week, make whatever changes we needed to make in order to be as well prepared for the final competition as possible. With that, there's a picture of our final design in the paint booth, and here is the actual design. So I will kind of go into, some of the components, but some of the main highlights here, as you can see on the poster, is a smooth releaser. So an actuator triggers upon the mechanism start to lift an anchoring bolt and release the main platform for functionality. So, here, if you can see, we've got this, we've got the release here. So what happens is this would come up, it knocks this wood plate. Once that wood plate is hit, it would release the machine as such. And then another part I want to highlight is our hoisted crane arm, which is a boom structure lowered and lifted from motor-driven hoist rope, great for moon placement. So you can see that here, which this is another iteration of it. So we're using rubber bands to, using rubber bands with momentum with pull this moon mechanism back, and the moon sits in here. But we actually, to raise this, we're using a kind of pulley system powered by a motor. So this basically rotates, and this piece of string is pulling up the hoist from this axle. And once it comes up in the air, it should be fully ejected to place the moon on top of the dome, as you can see here in the per the machine. So another thing I want to highlight as well is our sweeping blade, which is a curved swivel arm powered by a motor that avoids children and clears missiles. So powered by the motor, curved arm, and then basically here we've added these arms to the end to basically allow for more extension to clear the missiles. So this curve here is meant to provide clearance for the children in the middle of the competition base. So another thing we added to, this was basically put in here, this other arm to control the moon mechanism as far as, when we launch, to keep it from launching too early. And then we got our, of course, our MyRio box is right here. We've also got, this is our platform as the base for everything. So our motor was mounted to the front of this platform. We got our motor and pulley system, as I mentioned before, but also we did 2 drawer systems with a piece of wood in between to allow for maximum extension. And then that's pretty much it. As far as our progression, our average points earned per round, we did progressively better week by week. Started at 32.5, then went to 40 points, then went to 58.3. So with the final competition, definitely moving forward in the right direction. And, overall, this is our design where, we had a limited knowledge of doing design before this class, and we're just very proud of it. Thank you.